In this lecture, we're going to discuss additional examples for determining the determinant of a matrix by the pivotal element method. For example 1, given the following matrix A with the following elements 3, 4, negative 1, negative 2, 1, 3, 5, 2, 6, let us determine its determinant by the pivotal element method. So as we have said, for pivotal element method, we will choose the element containing unity or that is equal to 1. So in this case, we have element 2, 2. So we now consider its column and its row. So with that, we now have negative 1 raised to the ij of the pivotal element. So that's 2 plus 2. And then we have our matrix will be 3, 5, negative 1, and 6. And then we subtract the product of the elements that will lie corresponding to the element in our matrix. So for 3, that will now be minus 4 and negative 2. For 5, that will be minus 2 times negative 2. Then for 1, that will be minus 4 times 3. And for 6, that will be minus 2 and 3. Okay, so simplifying, negative 1 raised to 4 is a positive value. So 3 minus negative 8, we get 11. 5 minus negative 4 is 9. Negative 1 minus 12 is negative 13. 6 minus 6, we get 0. Okay? So from this, we can now solve our determinant by Saru's rule. So that will now be determinant of E is positive 11 times 0 minus negative 13 times 9, which will give us 117. Okay. So next example, matrix F, which is a 4 by 4 matrix. So by pivotal element method, we choose the element that will have unity or that is equal to 1. So we have several values equal to or elements equal to 1. So for this example, let us choose the element at 4, 1. Okay, so consider or we eliminate the row and the column of that element. So for our solution, the determinant of F will now be negative 1 raised to the position of our chosen pivotal element. That's 4 plus 1. Okay. And then in our matrix, we write this remaining, the minor matrix of our chosen pivot element. So we have 3, 2, 0, 3, 1, 1, 1, 3, 2. And again, we multiply the product of the elements along the row and column of the pivotal elements, which will be aligned on our elements. So for this element, we will now have minus 2 times 2. So for this element, we will have minus 3 times 2. For this element, we have minus 1 times 2. So for our second column, we have minus 3 or 2 times 1. Next, for this element, we will have 3 times 1. Then for this element, we'll have minus 1 times 1. Third column, for this element, that will be minus the product of this element, so minus 2 times 0. For this element, we'll have minus 3 times 0. Then we have for this element, we have minus 1 times 0. Simplifying now, matrix or the determinant of matrix F will be negative 1 raised to 5. So that will give us a negative value. So 3 minus 4 give us negative 1. 2 minus 6 is negative 4. 0 minus 2, negative 2. Next, we have 3 minus 2 is 1. 1 minus 3, negative 2. 1 minus 1, 0. 1 minus 2 is 1, or negative 1. And then we have 3 minus, or 1 minus 2. 0 is 1. 3 minus 0, 3. 2 minus 0 is 2. So we can solve already our determinant for matrix F. We could use Saros rule. So we could simply add up the products of the diagonal elements down minus the sum of the diagonals up. Or we could apply again pivotal element method. So if we're going to continue using pivotal element method, we again use with this new matrix, choose an element having a value of 1. So we have 2. So we can choose any of this. So in the solution, I'll be using this element A1, 2. So again, eliminate its column and its row. So we'll now have, we have a while ago a negative value. And then for the position of the second process, we have negative 1 raised to 1 plus 2. And then its minor matrix, we have negative 4, negative 2, 3, and 2. Again, we subtract the product of the element that is found on our eliminated row and column. So we have for negative 4, that will be minus negative 1 times negative 2. For 2, that will be minus this element, so minus 1, negative 1 times 0. For this element, that will be 1 and negative 2, so that's minus 1 times negative 2. For this element, we have 1 and 0, so it's minus 1 times 0. So simplifying, negative 1 raised to 3 is a negative value multiplied to a negative. That will now be a positive value, or it's negative times negative 1. Simplifying, we have negative 4 minus 2, it's negative 6. Negative 2 minus 0, we have negative 2. 3 minus negative 2 is 5. And 2 minus 0 is 2. Okay? So with that, we can now solve our determinant of matrix F by multiplying now 6 and 2 minus negative 2 times 5. We'll have now negative times negative multiplied 2, negative 12 minus negative 10. That will give us positive negative 2, or our final answer is negative 2, which is the same with the Laplace result as we have computed for problem number 20 in our lecture. So next example, matrix C. We solve for its determinant. So we have a 4 by 4 matrix. So we have several elements with 1. I'll be choosing this element. So we'll have now to eliminate its row and its column. So we'll have negative 1 raised to its position to 1. And then we write its minor matrix. So we'll have 14, negative 2, negative 4, 3, 2, negative 3, 1, negative 3, negative 4. Okay, so same process, we subtract the product of the elements that would be found along the same row and same column of the eliminated row and column. Okay, so for 14, that will be minus 2 times 5. For this element, we'll have minus 1 times 5 minus 3 times 5. For this element, we'll have minus 2 times negative 1. This element will have minus 1 times negative 1. This element will have minus 3 times negative 1. For this element, we will have minus 2 times 3. This element will have minus 3 times 1. This element will have 3 times 3. Okay, so simplifying, negative 1 raised to 3 is a negative value. So simplify the elements. Will now have 14 minus 10 and 4. Negative 2 minus 5, negative 7. Negative 4 minus 15, we have negative 19. 3 minus negative 2, 5. 2 minus negative 1, 3. Negative 3 minus negative 3, 0. 1 minus 6, negative 5. Negative 3 minus 3 is negative 6. Negative 4 minus 9, get negative 30. So again, we have a 3 by 3 matrix, so we could apply Saru's rule already to solve for the matrix. And whatever value we get from Saru's rule will also get the same value if we are going to continue with the pivotal element method. So if we're going to continue by pivotal element method, we do not have elements equal to 1. So what will we do? We choose any element inside our matrix that we would like to convert or reduce to 1. So in this case, I'll be choosing the element 1, 1, which is equal to 4. So what I will do is to reduce this to 1 by dividing all of the elements on row 1 by 4. So we'll now arrive, so I'll be removing 4 and putting it outside. We'll have negative 4. So the second and third row remains the same. And then the first row will now become 4 divided by 4, that's 1. Then we'll have 5 over 4 and negative 5 over 4. So with this, we can now apply pivotal element method. So we eliminate the row and the column. Then that will now be negative 4 times negative 1 raised to the position of our pivotal element, 1 plus 1. Then write our minor matrix, that will now be 3, 0, negative 6, negative 13. Then multiply again or subtract again the product of the elements that will be aligned with our element found on our eliminated row and column. So in this case, for this element, we will now have minus 5 over 4 times negative 7. For this element, we'll have minus 5 over 4 times negative 19. Then this one will have minus negative 5 over 4 times negative 7. And for this element, we will have minus negative 5 over 4 times negative 19. Okay, so let's copy this matrix. Okay, so with that, we have negative 4. Simplify now our values. So 3 minus 5 over 4 times negative 7, we get 47 over 4. Then 0 minus 5 over 4 times negative 19 gives us 95 over 4. Negative 6 minus negative 5 over 4 times negative 7 gives us negative 15 over 4. Negative 13 minus negative 5 over 4 times minus negative 19 gives us negative 147 all over 4. So we can now apply Saru's rule. 47 over 4 times negative 147 over 4 will give us negative 6909 over 16. 95 times 59 divided by 4 and 4 will give us negative 5605 over 16. So simplifying the elements inside our matrix, so we'll have negative 163 over 2. And multiply now negative 4 to this element will now arrive at a value of 326. Okay, so meaning the element of matrix, the determinant of matrix C is now equal to 326. So you can check our values by solving for the determinant by Saru's rule through our 3 by 3 matrix, or you can use other values for as our pivotal element. You must get the same value of 326. Another example, matrix E, which is a 4 by 4 matrix. So in this solution, I will be choosing the single unity element at 3, 2. So we'll eliminate temporarily its column and its row. So from there, we now have the determinant of matrix E is equal to negative 1 raised to its position 3 plus 2. And then we write the minor matrix. So we have negative 2, 5, negative 4, negative 3, 0, 7, negative 4, 2, negative 9. And then we subtract the product of the elements that coincides with the respective element inside the eliminated row and column. So for this element, we'll have minus 8 times 2. And then we'll have here minus 8 times 4. And then for this element, we have 8 times negative 5. So for this element, we'll have 2 and 8. So that's minus 2 times negative 8. For this element, we'll have 4 and negative 8. So that's 0 minus 4 times negative 8. For this element, we'll have minus negative 5 times negative 8. Then for this element, we'll have 2 and negative 1. For this element, we'll have 4 and negative 1. And lastly, for this element, we'll have 1 and 5. Negative 5 and negative 1. So simplifying, negative 1 raised to 5 will give us a negative value. Negative 2 minus 16 is negative 18. 5 minus 32 is negative 27. Negative 4 minus negative 40 gives us 36. Negative 3 minus negative 16 is 13. 0 minus negative 32 is 32. 7 minus 40, negative 33. Negative 4 minus negative 2 is negative 2. 2 minus negative 4 is 6. Negative 9 minus 5 is negative 14. So another way of solving for our determinant, so we could use the Sarus rule already, or if we're going to continue with the pivotal element method, we are going to choose any element that's equal to 1, but in this case, we do not have an element equal to 1, so we could choose a number that we will reduce to 1. In this case, I'll be choosing element 1, 3, so that's negative 2. So what I will do is to take out negative 2, okay, and then write the minor matrix of the chosen element. And we have negative 27, 36, 32, and negative 33. So same process for negative 27. We subtract the product of negative 18 and 6. But take note, we have to reduce this row by negative 2. So that will become now negative 18 times 6 divided by negative 2. So next, for this element, it will now be negative 18 and negative 14. And we have simplified, or we are going to simplify this row by dividing it to negative 2. So we'll now have minus negative 18 times negative 14 all over negative 2. Then, for this element, we have 13 and 6 divided by negative 2. And for the last element, we'll have 13 and negative 14 divided by negative 2. So simplifying our elements here, and the factor negative 2 will only be distributed to the first row. So we'll now have negative, or that will be 162, 162, negative 142, and negative 124 respectively. So this negative 1 raised to 1 plus 3 comes from the position of our chosen pivot element for the second procedure, element 1, 3. And that will give us a positive value. So therefore, negative times positive will still give us a negative value. So from there, we can now compute 162 times negative 124 minus 162 times negative 142 will give us 2916. Or our final answer now for the determinant of matrix E is negative 2916.